Right, hello. In this presentation, I will be explaining about presentation of data. The materials are mostly relevant to DP, Met as LAA, but it may also relevant for other subjects such as Met AI. Yeah, right. Let's begin with the type of data. When we are about to present our data, first thing first, we need to decide whether our data is discrete or continuous. So let's go through these two type of data. Discrete data is basically something that you can count. Okay? For example, the number of people, number of fruits. Okay, so those are discrete data, right? And this is the example of how we can present discrete data using a column graph or bar graph, and this is related to melting point in Kelvin against atomic numbers. So these are the atomic number in the x-axis, and here is the melting point. Notice that there's a gap in between bars, yeah, because this is a set of discrete data. Yeah. And the next type is continuous data. It is basically data that you measured. Yeah? For example, temperature, acceleration, length. Yeah, those are continuous data, right? And here is an example of how we can present continuous data. Uh, Notice that this curve is continuous, no gap in between, yeah, because the data is continuous, right? So just to recap, again, discrete data is the data that you can count. Continuous data is data that you measure. For example, number of pages in a book is a discrete data. Length of a film is a continuous data. Shoe size, well, this is a bit tricky. It is a discrete data because, for example, you only have uh, a shoe size of 5, 5.5, 6, 6.5, etc. You have nothing in between. You don't have 5.1, 5.11. You don't have those. Yeah, that's why it is considered a discrete data. Temperature is a continuous data, obviously. A number of people is a discrete data, and the time taken is a continuous data. Yeah. Then, knowing the type of data, how do we present uh, the data? That will come next. This is actually very common. I'm sure you have come across this before. We can present our data using frequency distribution table. And that's the simplest way to present the data. What is this? It's basically a table that lists all of the items and shows the number of times the items occur. Yeah, that's frequency distribution table. For example, consider this data set. Yeah, what we usually do, we will count how many number ones, how many number twos, how many number threes, and so on, using the stick here, right? And when it get to 5, we cross it like so, right? This is very common. And we'll list all of the items, and we tally them, yeah, and the total tally uh, equal to the frequency. So for example, for value 1 or for item 1, there are 8, yep, and here there are 9s of value 2. Here there are 6 of value 3, and so on, and the total is 30. Yeah. So that's one way to present the data. And this is discrete data. But what about continuous data? Uh, well, for continuous data, takes a bit of effort. There are several steps that we have to go through. Okay, let's take a look at this example. The data here shows the distance in meters that Agus threw a baseball, right? Well, again, these are clearly a set of these are continuous data, yeah. The data that you measured. Okay, first thing first, step one, you need to pick a convenience starting and ending values. Yeah, so you must pick the starting and ending values first. The starting value can be lower than the lowest value, and the ending value can be higher than the highest value of the data. Well, the lowest value of the data is 62.3. So what we do, we lower it down to a more convenient value, which is into 60, and the highest value is 97.5, and we round this up to 100, which is more convenience. Yeah. So here are the starting and ending values. Okay, let's take a look at step 2. Here in step 2, you will need to choose a class width. Yeah, you need to choose a class width, but you cannot use a formula because we don't know the number of classes. Okay, let me just show you the formula. So, okay, this is usually the formula used to find either class width or number of classes. And you can see in this question, we don't know the number of classes, we don't know the class width. So we need to have a guess on the class width. A class width is usually an odd number, yeah, because with odd number we can choose the middle the of a class, yeah. So that's the reason. And the common class width is 5. Yeah? Or you can choose a class width so that there are about 6 to 12 number of classes inclusive. Let's try with 5. Okay, class width equal to 5. Okay, we know the highest value from the data, which is 97.5. We know the lowest value, which is 62.3. Divide this by 5, that gives us 7.04. And sorry, let me just go back a bit. One of the rules says whatever value you have, then you round it up. So this is just equal to 8. So the number of classes is 8, which satisfies this, because you must have 6 to 12 number of classes. Yeah. If the number of classes is given, right? So say we know the number of classes, then you may use this formula directly, right? Okay. Right, now let's present this set of data into a frequency table first. Okay. Please take note, this is taken from the subject guide, and it says class intervals will be given as inequalities without gaps. Right, so let's present it. There you go. So we are using inequalities, yeah, in each class intervals in the case of continuous data, yeah. And we label our table here. This is for distance, and this column is tally, and this column is of course frequency. For class width, take a look at this row. Yeah, the class width is 5, and each of these again is called class interval. Yeah, for example, this one here, 60 is less than or equal to d being the distance, and this is less than 65. That is an example of class interval. Then we can generate the histogram. The x-axis, of course, is the distance in meters, and the y-axis is, of course, the frequency. So for example, if we take a look at this particular interval, yeah, which is the one there, the height corresponds to the frequency. Yeah, there you go. Let's take a look at another example. Here is from discrete data, and notice the difference. In discrete data, there are gaps between bars, yeah, and this is called bar chart or column graph, yeah. So that's the difference. Okay, we have seen how to present continuous data. We use histogram, yeah, bar graph with no gaps. So what I will do next is just to see a couple of more examples where we present continuous data. Okay, let's start off with the definition of histogram. It is a set of bars that give a picture of the distribution of data, and it is used to graph continuous grouped data. Yeah. Then why do we use histogram? Because it can display large data sets. It is usually used when the data set consists of 100 values or more. Okay, so again, just to remind you the difference between the bar graph or column graph and histogram. Yeah, in histogram there are no gaps, and in this level Mat AA SL, please note that you are not required to learn about frequency density histogram. Yeah, so this particular part will not be discussed in this video. Frequency density histogram. Okay, now let's take a look at this example. This data is taken from how far Abdullah, a professional golfer, hit 30 drive on a practice. Okay, and the instruction is you are to create a relevant histogram of the given data. And as before, the first step is for you to pick a convenience starting and ending values. Well, the lowest value here is 243.6. So we adjust it to a more convenient value. Therefore, the starting value is 240. Okay, 240 is the starting value. And for the ending value, we refer to the highest value, which is 278.9. We round this up and it becomes 280. So here are the starting and ending values. Moving on to the second step. Here we are not given the class width and we are not given the number of classes. So what we can do, we can begin by guessing a class width, right? And we choose a class width which is an odd number, because with an odd number we can have an integer class midpoint. So that's the reason why an odd number is used for a class width, and the common one is 5. Or you can choose a class width so that there are about 6 to 12 number of classes. Okay, we are going to use this formula, and just to repeat, we don't know number of classes, we don't know the class width. All we know is the highest value and the lowest value, and I'm going to have a go with 5 as a class width, and hopefully I can come up with 6 to 12 number of classes. So let's take a look. So number of classes is equal to the highest value subtracted by the lowest value, so that one there, lowest value, highest value, divided by the class width, which is 5. If you calculate it, the answer is actually 7.06, but the rule is you always round up. That's why the number of classes is 8, right? Okay. So here in the next step, we are going to present the data in using frequency distribution table. Yeah. So we put the data into the table first, and again, based on the syllabus. Okay, syllabus say class intervals will be given as inequalities without gaps. Right. So there you go. So we have the distance column, tally, and frequency, and we have 1, 2, 3, 4, 5, 6, 7, 8 number of classes. All right. Then we can present this data with the help of this frequency distribution table into a histogram, like so. It is very important when you write your IA, make sure that each graph must be titled and each axis must be labeled. Yeah. Right. Moving on to the last example. Here the question says a sample of 20 juvenile lobsters is randomly selected from a tank containing several hundred. Each lobster is measured for length in centimeter, and the results are given below. Right? But here we are given 5 number of classes, so we can directly use the formula. Okay, so we are given 5 number of classes, and we were told to organize the data using a frequency table and produce the histogram. So we must produce frequency table like before and produce the histogram. Okay, step 1, always pick convenience starting and ending values. Right, the lowest value is 3.1, highest value is 7.3. So the starting value would be 3 and ending value would be 8. Right? Then we can use this formula to find the class width. So the maximum value is 7.3 and minimum value is 3.1. Yeah. Divided by 5, and that's equal to 0.84. And we always round up. Yeah. We always round up the value that we get here. So the class width is 1. Okay. And knowing this, we can then produce the frequency distribution table, like so. See that? See that the class width is 1. Okay. And we have the frequency. Okay. This time the tally column is not included. Right. Then we can produce the histogram. There you go. I hope this video helps you understand more about how to present the data. Right? Thank you very much. Take care.